Please open in your learning workbook to page 207. We're going to learn our next logarithmic property, the power property of logarithms. The power property of logarithms states that log base a of the argument m to the p power equals p times log base a of m. It can be used to move a log's argument's exponent to the front of the log. It can also be used to move a factor in front of a log to become the exponent of the log's argument. Let's take a look at this rule in detail. So on the left side, we have log base a of this exponential expression, m to the p power. On the right side, we notice that the p is no longer the exponent of the argument and has in fact been moved to the front of the logarithm. So this important property allows us to take an argument that contains an exponent and move that exponent to the front of the log so that the argument no longer contains an exponent. Now, as with all log rules, this is bidirectional, so it can be used from right to left. If someone gives you a logarithm that has a number in front of it multiplying by that logarithm, you can get rid of that number by moving it to become the exponent of the argument. So here's what I really want you to pay attention to. The argument is different. On the left, it's m to the p power. On the right, it's just m. Okay, let's apply the power property, I said the wrong name. Apply the power property of logarithms. So we're going to do this problem right here, and we're going to apply the power property. So we can see that what we have here is the logarithm of an argument where the argument has an exponent. So that is the left side of the rule that we see here. So I'm going to go ahead and write this rule directly above what we're given in the problem, and we're going to line everything up. Now, the first thing we need to recognize is that when log is written without a base, the implied base is a 10. Okay, so let's find out what goes with where. So we can see that when we compare these, the base is 10, so the value of a is going to be 10. We can see that the argument is x squared, and when we line that up with the rule, we see that m goes with x and p goes with 2. So when we write this on the other side, we just have to replace the symbols. P is going to become 2, log base, a is going to be written as 10, of m, which is going to be written as x. And then as a final gesture, we note that log base 10 can just be written log, so we get 2 log of x. Okay, second example. In this one, we're given an equation, and there's a question mark, and we have to find out the value of the question mark. And the way we're going to do that is by rewriting what they give us on the left-hand side of the equation. Well, if you look carefully, you'll see that what's on the left-hand side of the equation looks like the right-hand side of our log rule. It has a number multiplying by the log. So I'm going to write the log rule again directly above this. P log base a of m equals log base a of m to the p power. And we're going to rewrite this part using the log rule. Okay, so what goes with what? So the first thing that we notice here is we've got a multiplying number outside for our log, which is this 2. So that's going to be the p. The next thing that I notice is that our base 6 corresponds with the a. The next thing I notice is that the argument 5 corresponds with the m. So if I wanted to rewrite the other side, the way I would do that is I would replace the a with 6, which you'll notice we already have, the m with 5, so we're going to need to put that in there, and the p with 2. So this thing that goes in that little question mark box, the thing that we have to put in there needs to be 5 to the second power. That's what goes inside the question mark box. Of course, 5 to the second power is 25, so I can write this as log base 6 of 25. And since the whole goal of this problem is to figure out what to put inside the question mark box, we're now done with this problem. We can say that it is 25. All right, so now that we've looked at both of these in detail, let's look at them holistically instead, okay? Going back to the original problem statement for this problem over here, we had log of x squared. So, thinking our way through this rule, what we understand is that the argument exponent can be moved in front of the log. So the 2 moves here, and we get 2 log of x. With this problem over here, the original problem statement said two log base 6 of 5 equals log base 6 of blank. And we can answer this in our head by using this log rule. The 2 has to move over here to become the exponent of the 5. So this gives us log base 6 of 5 squared. So that must equal log base 6 of 25, because 5 squared is 25.